steady state and equilibrium. We are going to be using the terms steady state and equilibrium, and we are going to discuss what we mean by these. We're also going to discuss what is the difference between them. A system is at steady state if its properties do not change with time, even though it is exchanging energy or mass with the surroundings. We have a light bulb which is operating, so we are supplying it electrical power and it is losing heat and light to the surroundings. The properties of the system are constant, so its temperature, for example, is constant, even though it is interacting with the surroundings. A system which is left isolated reaches a state of equilibrium, where its properties do not change with time. We have a ball which is sitting on this table. This is an isolated system because it is not interacting with the surroundings. Now, if we disturb it, it'll fall down and eventually it'll reach a new state of equilibrium. Here we've got an insulated container which is filled with gas. This is a system which is isolated and its properties are constant, therefore it is in equilibrium. We place a hot metal bar inside this. The bar will lose heat to the gas, and the gas will heat up, and eventually it'll reach a state of equilibrium where the bar and the gas are both at the same temperature. Now, this is an isolated system which is in a state of equilibrium, and the properties will not change further. Here we've got a glass of water which is placed underneath a tap, and the amount of water inside it is changing and it is rising. So this is a state which we call transient. Eventually the level of water will start overflowing and the amount of water is now constant, even though there's mass entering and mass leaving the system. This is therefore what we would call a system at steady state. If we turn the tap off and we leave the water, then it is an isolated system, it is not interacting with the surroundings, and the properties are now constant, so we would call this a state of equilibrium. So systems which are at equilibrium do not interact with the surroundings, and that means that they cannot do work. A system can do work only when it is not in equilibrium. Here we've got a ball which is sitting on a ledge of height h. The ball is at equilibrium because it is isolated, it is not interacting with the surroundings. But if we disturb the ball so that it falls, it will turn the wheel, and we can use that to do work. The ball, however, will eventually reach a new state of equilibrium. If we want to calculate the change in potential energy between the initial and the final equilibrium state, that is given by mgh. And this, therefore, sets an upper limit on the maximum amount of work that can be done by the system, which is mgh. Work can also be done by expansion of a gas. So here we have a cylinder which is filled with gas, and it has a movable piston. We bring a hot mass, which is at a temperature Th, in contact with the gas. The gas will expand, and in doing so, it will do work on the surroundings. Eventually, however, it will reach a state of equilibrium where the temperature of the gas is Th. After this, it cannot do any further work on the surroundings. We have an insulated cylinder over here with a piston which is held in place with a locking pin. The pressure on the two sides of the piston is different. It's P1 on one face and P2 on the other. Now, if we remove the pin, the piston will move until it reaches a state of equilibrium where the pressure on both sides of the piston is the same. It is now in a state of mechanical equilibrium, where the pressure throughout the system is uniform. Here we have two masses which are at different temperatures, T1 and T2. We bring them in contact with each other and insulate it so that the system is isolated. Eventually, the temperature of both the masses becomes the same. They are then said to be in a state of thermal equilibrium, where the temperature throughout the system is uniform. Here we've got a container which is partially filled with liquid, and there's a vacuum above that. The liquid will start evaporating, and the vapor will fill the vacuum. The liquid level will then decrease. Eventually, we will reach a state of equilibrium, and this is called phase equilibrium. The pressure and the temperature throughout the system are uniform, and the amounts of the two phases will also remain constant. To summarize, steady state is when a system property do not change with time, even though the system interacts with the surroundings. An isolated system reaches a state of equilibrium when its properties do not change with time. Mechanical equilibrium is when the pressure throughout the system is uniform. Thermal equilibrium is when the temperature throughout the system is uniform. And phase equilibrium is when the pressure and temperature throughout the system are uniform and the amount of the two phases within the system remain constant.